characteristics of the Prince Rupert's drops and what makes them so fascinating. Tell us a little bit about how one stumbles upon such a problem, and what was the process like? I'm sure it was the process itself would have been very fascinating and rewarding.
Both metaphorically and physically, Prince Rupert's drops took me to some very interesting places. First of all, the problem was introduced to me by a colleague who was visiting Purdue for over a period of 6 years. He was professor of mechanics at Cambridge. He was an emeritus professor. Bill Johnson was very well known as one of the pioneers of metal forming, but he was also, in those days, um, you know, um, there were very good mechanicians who were also very good manufacturing people. I mean, he studied problems in plasticity, but all driven by interests in manufacturing. And there are a number of instances like this. Since Mahesh is in fluid mechanics, I'd like to draw attention to a couple of people. One of which is Theodor von Karman. We know him as a fluid mechanician, but he did pioneering work in rolling of metals.
Oh, I didn't know.
And then G.I. Taylor. I thought of him as a solid mechanician till I looked at his collected papers and said, "Oh, he must be a." His
Sure.
contributions to fluid mechanics are as much or more. And J. Taylor is one of the three discoverers of this concept called defect called the dislocation in metals. And he, Orowan, and Polanyi, they came to this. They realized the need for the existence of this defect called dislocation quite analytically from different routes. And dislocations are the basis of plasticity in metals, that is, the ability to shape metals, which means doing things like metal forming, metal cutting, etc. And G.I. Taylor himself did a lot of work in what I would loosely call manufacturing processes. And incidentally, he was also the inventor of the plowshare anchor, which is one of the most widely used anchors for ships. So these people were, besides being fundamental scientists, they were also very good applied engineers, right? But anyway, Bill Johnson introduced me to this problem of Rupert's drops and said, these are glass drops which are made by just heating a piece of glass rod and quenching the molten drop in water. And you get a tear-shaped drop. And they have these peculiar properties that you can take the drop and you bang the head, pretty hard against a hammer or even more severely, and the drop would not break. On the other hand, if you snip its tail, it'll explode into powder. So this had intrigued so-called natural philosophers from the 1600s. There are lots of names associated with it, like Huygens, Hooke, Newton, etc. And it also has a very strong connection with the founding of the Royal Society, which is the oldest scientific society in the world. Rupert's drops, some of the reports on Rupert's drops. Prince Rupert was a minor prince of the Rhine in Germany, and he brought some of these drops and gave them to King Charles II. And the drops he brought were made out of colored glass, wine glass. And usually these drops, if you go on the web and look at them, they'll always have some bubbles inside. And Rupert told Charles that these bubbles contain liquor. So Charles was intrigued by that fact more than the explosion, and he wanted his scientists to explain to him various things about Rupert's drops. So Johnson said, hey, there's these drops, very interesting. They're very strong in the head. When you snip the tail, they explode into powder. So maybe if you do high-speed photography, we could decipher why it behaves the way it does. How does it disintegrate? So at that time, I was going to Cambridge in England, and Cambridge University the Cavendish Laboratory had probably the best high-speed photography group in the world. And so I was able to make a connection with a gentleman named Munawar Chowdhury. He's from Lahore originally. His father had got his PhD with Rutherford in Cambridge. And so he was he's truly remarkable person, extremely good experimentalist. Certainly so in high-speed photography, and so we were able to actually observe the disintegration of the drop.